Welcome back to another session on data structures. So in this particular session, we are going to study a completely new data structure. But before I introduce you to that particular data structure, I would like to take a disadvantage of the data structure that we have already studied. Now what is the data structure that we have already studied? One of the majorly used data structure, that's nothing but arrays. So, in case of arrays, there are certain disadvantages and I am going to point out those particular disadvantages and then I am going to bring in this particular new data structure which will actually overcome all the disadvantages that's there in case of array data structure. So, now let's try to understand what exactly the problem is. So, one thing that you need to understand is whenever you write any kind of program, there are two things over there. In that particular program, one thing is you are actually making use of the variables, or I can even say you are storing some kind of data in that particular program. At the same time, you are manipulating that data. Now, how are you manipulating that particular data? By writing some set of instructions like for, if and all of these particular things. And you will be using a different data structure, maybe an array or a string or maybe array list or anything as such. Now, you already know that there are two things that you are doing. One is storing the data and the other one is manipulating the data. Now let's focus on storing the data. Now whenever you are storing a data, you make use of variables. Now where exactly are these variables created is a question mark. Now if you ask me where exactly is it created, whenever you write programs in any particular language, what happens is a memory is allocated for that particular program. Now where is that memory allocated? It's allocated in the RAM. So in case of RAM, there is a physical memory which is allocated for your program and all the variables store the data in that particular physical memory. Now let's assume this is the memory that I have. Now in this particular memory, whenever you create a new variable, a new block of memory gets occupied. So same way you might be creating new variables multiple times and you might be deleting that variables multiple times. So there will be a lot of memory which is occupied and lot of memory which is not occupied. Now one thing that I need to understand over here is, in case if I am creating one variable of 1 byte, then I will just occupy 1 byte. But in case if I am creating an array or a list, what exactly happens in this case is, it doesn't require just 1 byte, it needs multiple bytes. Why multiple bytes? Because in case of array or in case of list, what exactly happens is a contiguous memory of elements are stored. Now for example, if you say 10 particular elements, so you need to store 10 elements in 10 different memory allocations. Now you can't store 10 anywhere that you wish to store. The language would take care of storing all these elements one next to the other. So you need contiguous memory allocations. Now what happens in this case is, let's assume that there are a lot of spaces available in your particular memory. Now in this particular case, if your language is looking for 10 contiguous memory allocations, there might be a possibility that there might not be 10 contiguous memory allocations available in your case. So this is the situation that I am saying. Now in this case, if you observe the complete memory, what exactly happens is, there are a lot more than 10 memory already available. But since 10 are not available contiguously, you won't be able to create an array or you won't be able to create a list. Now how can we overcome this particular challenge is when this particular new data structure comes into picture. So this is one of the major disadvantages when it comes to an array. Now there are certain other disadvantages as well. Now to take that other disadvantages, let me just remove this particular memory and let me just bring this particular array over here. Now in case of array or in case of list, what usually happens is, the memory which whatever you are allocating, that is predefined. So what do I mean by predefined? You have to say to your language, for example in case of Java, if you want 5 elements to be stored, you have to mention while creating the array itself that you need 5 memory, which that you need to store 5 elements over there. But when it comes to Python, what exactly happens is, you are not saying that you need 5 elements to be stored, but Python automatically will allocate some memory whichever you are asking for, plus and some more, and with all of these things you would have already studied in your Python whenever you were studying list as well. So let's assume a situation that I have an array over here of size 11. Now in this particular array, I need to add a new element. Now I don't want to add this new element to the end of the array. Rather, I need to add this new element somewhere in between, or the worst case situation is I need to add the element to the first index or to the 0th index or at the beginning of the array or a list. Now how can I do this? Now you can clearly see over here, there is no free memory available over here. Since there is no free memory available, there is no way that I can create a new memory and attach it over here. Rather, what I need to do over here is I need to shift all the elements one index towards its right side. Now how can I do that? In case I need to create a new block over here, and after that I need to shift this 17 which is present in index 10 to index 11. I need to shift this element 12 from index 9 to index 10. Same way I need to shift element 3 from index 8 to index 9, and I need to do this for all the elements till the starting. Now when I do to all the elements till the starting, one free memory will be available over here. Now when this free memory is available, whatever element that I wanted to add, I can add it over here. So now if you ask me how many shifting operations happened, how many other elements were available over here, so many number of shifting operations you have to do. So assume there is an array of size 5000 or 10,000. So if the size is 10,000, you need to do this shifting operation 10,000 times, and only then you can add a new element, or else you won't be able to add. So this is one more disadvantage when it comes to an array. Now there is one more disadvantage. If there is a problem in adding the element at the starting, then definitely there is a problem in removing the element from the beginning of this particular array. Now what is the problem? Assume now we already have 12. I don't want to remove this 12. Now when I remove this 12 from here, either this memory will be empty or it is unused. So what I need to do is, in 0th index, I don't want 12 over here, rather it should be 5, the next element should be 7. Now I can't simply remove this, rather what I need to do is, I need to shift all the elements one index towards its left side from the starting till the end. If I do that, only then it means to say that I have removed the first element. So these are the disadvantages of it. Now, who will actually overcome all this disadvantage if you ask me? Linked list is a data structure which will actually overcome all the disadvantages I mentioned it over here. Now how will it overcome? Let's try to understand from the memory level first. So let's assume if I bring back all the memories over here. So this is how your RAM looks like. Now assume that I need to create an element which or create an array which shows 4 elements. And I will make sure that in this particular memory what exactly is happening is there is no 4 free elements or 4 free blocks which are continuously available for free. So what I need to do, I can make use of any 4 whichever is available in this whole memory. Now how can I make use of any 4? What I would do is all this memory whichever is available is completely dispersed. So I will make use of any 4. So which 4 I would make use is, I would make use of this memory, I would make use of this memory and this particular memory. So when I make use of these 4 memory, yes, I can store the elements. Now since there were more than 4 bytes available, I could store this element. But there is one more problem which occurs over here. And if you ask me what is the problem that's occurring over here, what exactly is happening over here is, I am not able to say this is my first element, this is my second element, this is my third element, and this is my fourth element. Now while seeing, since I created in this order, I know it. But how does your language know it? Either you are writing in Python or in Java, you don't know. So even your language also would not know. Now how can I make sure that even your language knows that this is your first element, this is your second element, this is your third element, and this is your fourth element? Now this can be solved in a very simple way. How, if you ask me? It's very simple. There is one more thing that I need to understand over here. And what's another thing if you ask me? Each and every block that is available over here, each and every block in this particular memory has a given address. Like for example, how in a map, every location will have a pin code or an address. The exact same way, every block over here will have an address. Now what I need to do is, I need to make use of this address. So what I am going to do is, let's assume this is the address of this memory, this is the address of this memory, this is the address of this memory, and this is the address of this memory. Once I get the address, it's very simple. All that I need to do is, instead of just storing the element over here, I would like to utilize one more block of element. Now what is the purpose of another block of a memory if you ask me? This block of memory will point to the next element. Now how does it point to the next element? Very simple. Since this particular memory also has an address, it will take the address of this memory and it will place it. Same way. Say now over here this is the next block is empty as of now. So I can utilize this particular block to store the address of the next element. So then address of the next element is this over here. So this I would like to store. So once I store it over here, automatically it says the next element is this. Same way. Now what I would like to do is, over here the block is empty. So what I would like to do is, I would like to store the address of the next element. So this is the address, I would like to store it over here. So automatically one connection is established over here. Now you know that this is the last element. If this is the last element, then there is no element after this. So what I would like to store over here, if you ask me, I would like to leave it as empty. Usually it is said in programming languages as null. So this particular block would be null. Now let's only focus on the memory which we are allocated. Or rest all of them I would like to leave. So this is how the linking actually happens. Now what exactly has happened is, in each block I have created a new block which has two partitions. One partition where the element is available and the other partition where actually the address is available. Now this particular way of linking multiple elements is what we consider as linked list, and this is what a linked list data structure is. Now there is one more thing which is missing. This I don't know which exactly is the first element. So to know the first element, what I need to do is I need to point one more variable to this particular address. So in my case, or in usually in linked list, this particular element which comes at the starting or the first element is always called as head. So I will store this particular address of this inside a new variable and I'll name it as head. So how does this look like? Like if I arrange all of them properly, this is how it would look. Now, actually when you are writing a program, all of this addressing whatever I have written over here is all dummy addresses. Only what concerns me the most in all of this, if you ask me, the only thing I am concerned about is these values 10, 20, 30 and 40. That's all I am concerned. So if I want to represent it in an easier way, I will remove all the addresses and this is how I can represent it. Now, one thing that you need to understand, this block of memory where there are two partitions, this is what we call as a node when it comes to a linked list. So if I take it out, the first part of the node is actually the element where the type of this particular element is integer as of now. Now it's not necessary that you need to store only integer type data. You can store string type data, you can store float point type data, or you can store even employee type or student type or any other user defined type as well. Now apart from this, the next block, whatever I have, actually stores the address. So whenever you are creating a new block, what exactly happens is, then always the second block will be empty, which is actually linking to the next element. Now if you want to link to the next element, you just have to store the address of the next element. Now how to write all of this in code, we will see that later, but this is what a linked list data structure is. Now how did it solve the disadvantages of arrays, if you ask me? One thing is very clear, I don't need contiguous memory for all of this. I need contiguous memory only to store two data over here. The next one can be anywhere in your RAM. So I need contiguous memory only for these two data. The next one can be anywhere in your RAM. You are just linking with the address of the next element. That's how it can be. You can solve the first disadvantage. The second disadvantage, what exactly happened is, in case if I have to insert a new element over here, it was a problem. Why exactly was a problem? Because I have to shift all the elements towards its right one side every time, and then if there are 10,000 elements, I have to shift them 10,000 times, and only then a new block of memory will be available and I could attach it over here. But in case of linked list, it's very simple. In case if I have to add a new element, all that I need to do is create a new node over here, and inside that node place the element that I need to do. So in my case I want 12, I will place 12, and after that all I need to do is just add this node over here at the starting, and head will start pointing to this node. That's all you have to do. Now if you have to delete this, just reverse this process. So you can clearly see there is no way that you are shifting. So in case of deleting, all that I need to do is just remove this particular block and make sure that the head points to the next element. So once this is done, you have taken care of all the disadvantages of an array over here, or an array list, or a list in that particular case. Now the question mark is, how can I create a node? How can I actually create this linked list would be a question mark. Now along with that, there are so many other things that we need to see when it comes to writing programs. How can I add the element at the starting? How can I add the element at the ending? How can I traverse this particular linked list? How can I reverse this linked list? And all of this is what we are going to study in this linked list data structure. And to see how to add an element, how to traverse the linked list, we will see in the next